Tina slowly, slowly. We be working all day long with a push of Spanish. We ain't playing no games. Sabatavi, Ngani.
Good day everyone. Today we are focusing on proving identities. So we're gonna prove number one, which is cos x times sin x plus sin squared x times tan x equals to tan x. So this is your left hand side, then this is your right hand side. So here I'm gonna take the one that is more complicated and try to simplify it. So this one is expanded, so this one is simplified. So I need to prove this side is the same with this one. So here I'm gonna change everything that I know. So I have cos, I will drop cos x, then I drop sin x, then I have sin squared, then I keep the sin squared, so I'm going to change tan x. We know the quotient identity, which is sin x over cos x. Bear in mind, ladies and gentlemen, this is your left hand side. So you drop cos x times sin x plus, if you multiply here, this one and this one, you're gonna get sin cube x over a cos x. Remember what we have here, it's 1. And then we're gonna multiply the denominators, then 1 times cos, you're gonna get cos x, then cos times cos x times sin x, you're gonna get cos squared x times sin x, then 1 times sin cube, you're gonna get plus sin cube x. Understand? So here we need to take out what is common. If you look at your denominator, at your numerator, you see that a sign is common here. If you take sign outside, you're gonna have cos squared x plus sin squared x all over cos x. Okay, now if you see what we have in the on the brackets, we can see that cos squared plus cos plus sin squared will give us 1 from your square identity, what you did in grade 11. So this is sin x times 1 over cos x. Oh, we know now that sine over cos will give us tan, so which is tan x. Now can you see that the left hand side now is equal to the right hand side? Now we can conclude, therefore, left hand side is equal to the what? To the right hand side. And then we take number 2. So number 2, we are proving cos x over 1 plus sin x plus 1 plus sin x over cos x is equal to 2 over cos x. So now guys, which side we need to take? Oh yes, now that's good. We're gonna take the left hand side. So if we're taking the left hand side, because the right hand side is simplified, there's no way that we can move here. So I'm gonna take the left hand side. On the left hand side we have cos over 1 plus sin x plus 1 plus sin x over cos x. Right, so I'm gonna put 1 division, then I multiply the numerators. Bear in mind guys that we need cos. So if I multiply this one, I'm gonna keep this one in the brackets, then I multiply by cos x, then this cos will multiply this cos, which is gonna have cos squared plus, so this one is gonna multiply here, which is gonna have 1 plus sin x times 1 plus sin x. So we drop cos squared. So if I multiply here guys, you are in grade 12. If you expand this one, you're gonna get 1 plus 2 sin x plus sin squared over, remember we're gonna keep this one because we need cos as your denominator there. So I have 1 plus sin x times cos x. Understand? So guys, we said in the previous example that cos squared plus sine squared give us 1. So this is the square identity. So I'm going to have 1 plus 1, another 1, this one, plus 2 sine x over 1 plus sine x times cos x. Okay, so 1 plus 1, you get what? 2 plus 2 sine x over 1 plus sine x times cos x. Okay, so what is common here, guys? Can you see that 2 here is common? So we're gonna factor out 2. If I take out 2 outside, I'm gonna have 1 plus sine x. Then we have on the denominator 1 plus sine x cos x. Can you see that what we want is 2 over cos? So this one is going to cancel this one. Now we are left with 2 over cos x. So that's your final answer. So can we now we can conclude that left hand side is equal to the what? To the right hand side. So I do believe in you that it's easy now. You can attempt question number 3, which is sine x. This one, sine x over 1 plus cos x plus 1 plus cos x over sine x equals to 2 over sine x. So same approach. You can do this. It's easy. You can do this. So let's skip number 3 and do number 4. So if we skip number 3 and do number 4, we are given 2 sine squared over 2 tan x minus sine 2x equals to cos over sine x. Bear in mind that, guys, this is grade 12 work now, because this identity involves the double angle, which is sine 2x. We don't do the double angles in grade 11, so we only do double angles in grade 12. So which side that, guys, we're gonna consider? This one, we know that it is the same as 1 over tan, but now they want us to get cos over sine. So whatever that you have on the numerator, you must make sure that you have cos. Then on the denominator, you must make sure that it's all sine. So I'm gonna take the left hand side. So the left hand side, I have 2 sine squared x over 2 tan x minus sine 2x. Right. So I'm gonna change this one from your square identity. So which is 2 into 1 minus cos squared x. Bear in mind, guys, we said that on the numerator we want everything to be in terms of cos. Then on the denominator we want everything to be in terms of sine. So this is 2. Then we change tan to become sine x over cos x, because we don't need tan. Minus, this is your double angle, which is 2 or sine x times cos x. Right. Now it's easy, guys, because if you consider this one, or you can take out 2 outside. So I have 2, 1 minus cos squared x over, if I take 2 outside, I'm going to have 2 inside. Then remember, you can work without this one. You will be left with sine x over cos x minus sine x times cos x. If you work out this one, is the same as sine x minus sine x times cos squared x all over cos times 1, which is cos. So can you see these 2 and 2 cancel out? Happy? So I'm left with 1 minus cos squared over sine x minus sine x times cos squared over cos. Now it's easy, good people. Very easy. Now we have 1 minus cos squared x. Remember, I'm going to put the division that we know, which is a divide. I'm going to say here, divide. So this division is this one. So then I have this fraction which is sine x. The common factor here is sine. I'm going to have 1 minus cos squared x over cos. Then we cannot have a 2 division in maths. So now I have 1 minus cos squared x. Then I will change the division to become multiplication. We do the reciprocal. So this one will become your numerator. So then you have cos x over sine x into 1 minus cos squared x. So you have 1 here, good people. Can you see this one is going to cancel this one? Now you are left with cos over sine. So which is cos x over sine x. Now we can conclude, because this is your final answer, which is the same as this one. So now we can conclude here. We can conclude, guys, that therefore the left hand side is equal to the right hand side. Understand? So that's number 4. Let's see what do we have next. Let's see what do we have next. So the next one, we are given. Okay, guys, we are still continuing with the proofs. Now we're gonna do this proof, which is so interesting. These proof, guys, they involve grade 12 and grade 11, but mostly grade 12. So here we are given sine 4 theta minus sine 2 theta all over cos 4 theta plus cos 2 theta equals to tan. So which side do you think, guys, we should take here and try to make it to look the same with other side? Obvious, it's the left hand side here. If I'm taking the left hand side, all right. So the left hand side, guys, we're given sine 4 theta minus sine 2 theta over cos 4 theta plus cos 2 theta, right? So in this case, guys, we are given this thing 4 is above your double angle, and this 4 is above your double angle. So notice that, guys, if I add 4 theta plus 2 theta, so the average between 4 theta and 2 theta in this case is going to be 3. Let's say if I added this one, 4 theta plus 2 theta divided by 2. 4 plus 2 theta, then you get 6. Then you divide by 2, then you get 3 theta. So notice that since the average is 3 between 4 and the 2, and also you have 4 and the 2 in the on the denominator, so notice, guys, that 4 theta can be presented as since the average is 3 theta, so the 4 theta can be represented as 3 theta plus theta, and the 2 theta can be presented since it's here, we can present this one, which is equals to 4 theta. We can also present 2 theta as 3 theta minus theta, which is give us 2 theta. So that's what we need to do, because we are going to apply your compound angles, guys. So this one does not have a max. So we're going to start here. I'm going to say sine into 3 theta plus theta minus sine. Remember, we have 2 theta now. We're going to say 3 theta minus theta. So all over, same thing, cos 3 theta plus theta minus cos 3 theta minus theta. Now it's all about using your compound angles, guys. So if I use compound angles now. This is A, this is your B, and this is your A, this is your B, this is your A, this is your B, A and a B. So it is simplified now, guys. Let's try to expand. Remember the compound angle of sine. It says sine cos cosine, and sine keeps the sign. But the compound angle of cos says coco, which is cos, sine, and cos changes the sign. So in this case, I'm going to have sine 3 theta cos theta. Remember, cos a sine keeps the sign. We're gonna say plus cos 3 theta sine theta. Then we are done with this one. Then we have this negative, guys, from the question. We have negative, and then to make my life easy, I'm going to put the brackets like this. Understand? So then you ask yourself, so the compound of sine again is going to be sine cos. So sine 3 theta cos theta. Remember, sine keeps the sign. So here I'm going to have symbol minus cos 3 theta sine theta. I ran out of space. I hope that you can see this is cos 3 theta times sine theta. So same thing here. The compound angle of cos is going to be cos 3 theta cos theta sine. Cos changes the sign, minus sine 3 theta sine. Oh, what's happening to my writing? Sine theta. Then we're done. Then we have this sign minus. So to make life easy again, I'm going to open the brackets. Remember the compound angle of cos 3 theta cos theta. Cos changes the sign, plus sine 3 theta sine theta. Okay, so guys, you drop this thing down again. This is sine 3 theta cos theta plus cos 3 theta sine theta. Then you open the brackets. Remember, guys, the negative times the positive. This is minus. Remember, we were having here sine 3 theta and the cos theta. So a negative times the positive, then you will get positive cos 3 theta sine theta. Okay, over. Then you drop again this one, cos 3 theta cos theta minus sine 3 theta sine theta. Then you open the brackets using your negative. So a negative and positive, then you will get negative. Then you will get a negative cos 3 theta cos theta. Then a negative times a positive. Now you get a negative sine 3 theta sine theta. Remember, guys, we want to prove a tan theta. So we want tan theta. Can you see that if I look at my numerator, these they will cancel out. These are like terms now. These are unlike terms, so they're gonna cancel out this one. So cos 3 theta times sine theta plus cos 3 theta times sine theta. So in the numerator, we're gonna have 2 cos 3 theta sine theta over. So let's look the numerator. So guys, can you see this one? Negative sine 3 theta times sine theta is going to cancel this one. All right. Am I correct? Let's look. Okay. This one, we have this sign, which is changes to become positive, minus, good, which is good. And then we are having this one, changes to become the cos. Okay, I'm just trying to think what's happening because this one is going to cancel out. Okay, how did we end up having oh, okay, sorry, I changed the question. It was given to be plus here, so supposed to be plus here. Sorry guys, this is plus here, this is plus here. Okay, I didn't see that positive. I ended up putting the minus, so please forgive me. I hope that you understand the working. So then cos 3 theta plus cos 3 theta. This one is going to give us 2 cos 3 theta times cos theta. The reason I ended up looking for what happened, what we missed, because if I subtract this one and subtract this one, I was going to get 0 on the denominator, which means if I get 0 on the denominator, the expression is undefined. So can you see now this will cancel out this one. Now we're left with sine over cos. We know that, guys, from the quotient rule, that a sine over cos will give us tan theta. So therefore the left hand side is equal to the right hand side. Are we together? If you are happy, then I'm happy. So guys, can you see this one? Even if you can try to attempt this one, or hope that you can attempt this one, same approach. We are given sine 8a minus sine 4a all over cos 8a plus cos 4a equals to tan 2a. Remember, you have to look for the average to make your life easy. If you add 8 plus 4, you will get 12. Then you divide by 2, then you get 6. Which means whatever that you do here, 6 must be involved. So if you say 6 plus 2, then you get 8. If you say 6 minus 2, you get 4. So same applies. Then you apply your compound angles. Thank you, guys. Breathe in, breathe out. Maths is good. Looking forward to see you next time. If you manage to get the answer, please don't hesitate to send it to me. So I'm going to share with you the number that you are going to share your answers. It's 0640 40 50 70. I repeat, 0640 40 50 70. Thank you. See you next time.